Hello everybody. Today we're going to talk about sequences. We're going to have 3 lessons in this unit. Lesson 1 will be on arithmetic sequences, lesson 2 on geometric, and then the third lesson will be on summation, sigma notation. So to start out, I just want to show you what a sequence is. A sequence is simply a list of numbers that follow a pattern. An arithmetic sequence is one where the next number you get by adding or subtracting the same thing every time. So let's say I start with 4. So it's called the common difference. We'll talk more about this in a minute. Let's say I want to add 5 every time. Well, if I start with 4, the next number would be 9. I added 5. 14, 19, 24, and so on, right? So this is a sequence because it follows a pattern and you can predict what the next number is going to be, 29. And not only that, it's arithmetic because we're adding the same thing every time. I could also subtract the same thing every time. Like let's say I start with 10 and I want to take away 3 each time. 7, 4, 1, -2, and so forth. So this is also arithmetic because I'm subtracting the same thing every time. Adding or subtracting, same number. And we call that the common difference. And we use the letter D for it. Okay. A geometric sequence is one where you get the same thing by, or you get the next term by, let me start over again. For geometric, you get the next term by multiplying or dividing by the same number every time. Let's start easy. Let's start with 1. Let's say I want to multiply by 2 every time. So I'd go 1, 2, 4, 8, 16, and so on. It's a sequence. See, we can predict the next number, 32, and it's geometric because I get the next number not by adding the same thing, but by multiplying the same thing. I could also divide. Let's say I started with 2,000, and I divide by 10 every time. Then I'd have 200, and then 20, and then 2, and then 0.2, and on you go. And I get the next term by dividing by the same thing. So geometric, you multiply or divide by same number. We call that number the common ratio. And we use the letter R for that. Now, it is possible to have a sequence that doesn't do either. A very common one is this one. 1, 4, 9, 16, 25, 36, 49. These are the perfect squares. It's a sequence. It follows a predictable pattern. Predictable meaning we can find, predictable meaning we can find the next term. However, I'm not adding the same thing every time. I'm not subtracting, multiplying, or dividing. So this is just a sequence. It's not either of these two special types. So our first lesson focuses on arithmetic sequences. So let's get rid of this and talk about arithmetic sequences. So let's start with there's formulas for sequences. There's an explicit formula, and this is for arithmetic specifically. And there's something called a recursive formula. I'll list that after. So an explicit formula So we can find any term we want with one calculation. Now, in order to make use of this, we have to unpack this language a little bit. Usually these subscripted numbers really mess with people. There's that D, the common difference. So let's do a specific example and try to make sense of this. This is an arithmetic sequence. I'm adding 3 every time. So see these subscripted A's, A with the little numbers? This is A sub 1, the first term. A sub 2 is the second term. A sub 3, A sub 4, A sub 5, and on you go. Out here somewhere, I don't know how far, there's a 6th, 7th, 8th, 9th. We call that the nth term. I don't know what it is because, you know, what do you want? The 11th term, the 50th term, the 100th term. All this means is showing a pattern. This is the first term, and this is whatever term you want. It could be the 50th term, it could be the 5,000th term, whatever you want. Okay, the common difference is what you add every time. Notice that I added 3. I added 3. I added 3. That's the common difference. So D equals 3, and the first term is 2. See, the first term is 2, and the common difference is 3. So for this particular sequence, the formula, this is the formula for all of them. For this specific one, I would have A sub n equals 2 plus 3 n minus 1. See, I replaced that with the first term and that with the common difference. The n's stay put. What do the n's do? What are they there for? I could say, find the 100th term. Now, I probably wouldn't want to actually list them. You know, this is the first, second, third, fourth, fifth. That's a lot of terms to do. That's what this formula is good for. If I want to know the 100th term, I don't have to sit there and figure it out. All I got to do is plug a 100 in for that n and crank that out, and that will be the 100th term. So let's see, this is going to be, that would be 299. 299, if I kept going out, 299 would be the 100th term, otherwise known as A sub 100. So, are you sure? Are you sure that's working? Let's say I wanted to know, let's see, 1, 2, 3, 4, fifth term. What is the fifth term? It should equal 14. Well, it's 2 plus 3 times 5. See, that's no accident. Those are both n's, minus 1. So this is 3 times 4. That's 12. 12 and 2. Yep, it's 14. So this formula allows you to calculate whatever term you want. Now there's another formula, which people don't like as much, called a recursive formula. And this gets a little weird. So we have A1 is some number. The first term, you got to say what that is. And then we get this really weird thing. A sub n plus 1 equals A sub n plus d. People really struggle with that. What does that mean? It means to get the next term. That's what that n plus 1. The next term. You take the current term and you add the common difference. So A sub n would be, we got to see how that plays out. What was that example I just erased? 2, 5, 8, 11, 14. So for this sequence, if I use this formula, I would say A sub 1 is 2. The first term is 2. And the next term would be the current term plus 3 because I'm adding 3 every time. How do you use this formula? Well, I go like this. The first term, let's do it like this. First term, given, it's 2. What's the second term? Well, the next one. The next term, a sub 2, would be equal to the current term, a sub 1, plus 3. What this is saying is that the second term is equal to the first term plus 3. What's the third term? Well, that would be the second one plus 3. What's the fourth term? Well, that would be the third term plus 3. See, what this formula is saying is, that's what this weird n plus 1 n stuff, it means to get the next one, you just take that one and add 3. To get the next one, you take that one and add 3. We're definitely going to do a few more examples of this. I know that this one in particular messes with people. All right, so I'm going to reorganize my board here. So we have explicit, specifically for arithmetic, which was this. And we have recursive, specifically for arithmetic. And that looks like this. All right, so let's do a couple examples here. So how about this sequence? 2 minus 8 minus 28. Okay, so the first thing I want to figure out is what's the common difference? Well, what am I adding every time? Plus, oh, actually I'm taking away. I took away 10, didn't I? 2 minus 10, minus 10, minus 10. So in this case, D is minus 10. That's what I'm changing every time I subtract 10. Okay? This is A1. The first term is 2. And the common difference is 10. Those numbers go in these, oh, not that one. These slots right there. So for this sequence, the explicit form would be AN equals the first term plus the common difference, which is actually minus 10 and minus 1. That would be my formula. The recursive formula would be the first term is 2, and to find the next term would be the current term minus 10. So basically this is where you start. Where you start. And this is what you do each time. I'm subtracting 10 each time, and I started with 2. All right, now this one you wouldn't really use for much. I'll just ask you to give me the formula. This one I would ask you to use. Like, let's find the 49th term. What would, this is 1, 2, 3, 4th term. What would the 49th one be without actually having to count it down? A49 means the 49th term. And that would equal 2 minus 10 to the 49 minus 1. So if I type that in my calculator, I would get the 49th term is negative 478. Okay, well, is that it? Almost. We're going to do one more thing. We're going to put this in reverse. What if I give you a formula? The directions will be find the first 5 terms. Okay? So let's say I give you this one, and this one, and this one, and this one. Now this is 4 separate problems. Imagine you're taking the test. Find the first 5 terms. This would be separate problems. So what your job would be to list the first 5 terms of the sequence. So here we go. The first term, I'll do my work over here. Here, how do I want to do this? I'll put my answer right here. So here's my work. The first term is 5 minus 3 times 1. So that would be 5 minus 3 is 2. The second term would be 5 minus 3 times 2. That's 5 minus 6 is negative 1. Notice I took away 3 there. The third term would be 5 minus 3 times 3. See? 1, 1, 2, 2, 3, 3, n, n. That'd be 5 minus 9 is negative 4. Okay. After I get the first few, once you see what the pattern is, see how you're taking away 3, I would just do this. But you could calculate them. We'll get the same numbers. Let's go again. The first term would be 10 plus 2 times 1. That's 12. The second term would be 10 plus 2 times 2, 14. The third term is 10 plus 2 times 3. Those got to match. That's 10, 60. Yep. So I'm adding 2 every time. Not an accident. So I think the next ones will be 18 and 20. Once you see what the pattern is, you can just fill them in. Now let's try these weird ones. Well, I give you the first term, 3. And it's all about understanding what this says. This says the next term, the one I want, is the current term, 3, take away 2. So that'd be 1. What's next? Well, the next term would be the current term, take away 2. See, this is what I'm doing each time. So the next one is minus 3 and minus 5. This one is saying start with 24 and add 6 every time. That's all that means. So this would be 24. The next term would be 30. The next is 36, 42, 48, and that would be it. Okay, so that covers arithmetic sequences and their formulas. Next lesson will be geometric. Be sure you practice these in your homework.